So now that we know how to calculate the molar mass for a molecule or a compound, let's explore further and see how we can use this in mole-mole conversions that involve the amount of substance and the mass of our molecules or compounds. So I'm turning to look at the teaching model number 2. And in the teaching model number 2, I see this diagram again that shows the conversion between molecules, the amount of substance, and the mass of substance. Except earlier when we saw this diagram, instead of molecules, it was atoms, for instance, or it could be any kind of particle. In this case, we're focusing on molecules. The conversion factors that are required, of course, are Avogadro's number to convert between molecules and the amount of substance. And of course, to convert between the amount of substance and mass, we've got the molar mass. So let's look at the key question number 2, where it says use a two-step approach to calculate the mass in grams of 3.011 times 10 to the 23 molecules of diethyl ether. So in this chart, we're starting with the number of molecules, and we can see in terms of a unit plan that we first of all need to convert the molecules to the amount of substance in moles. And then once we know the amount of substance, and if we know the molar mass, which we just calculated, we can determine the mass in grams. So again, usually in a test or an assignment, I won't ask you to write out the unit plan, but I find it helpful to keep myself organized and thinking about what is the nature of this calculation. Then putting the numbers in is actually quite trivial. So here's the actual calculation. So I'm starting with my quantity, 3.011 times 10 to the 23 molecules. I then convert to the amount of the diethyl ether using the conversion factor 1 mole of C4H10O per 6.022 times 10 to the 23. Note, I write in the word molecules because technically that is correct, but of course it gets kind of long-winded, so I'd understand if you don't include that. And then finally, we multiply by the molar mass, 74.12 grams per 1 mole of C4H10O. Everything cancels, and we end up with the mass in grams. Again, note that when these questions are being asked, usually we wouldn't say use a two-step approach, but rather we would just say calculate the mass in grams for this number of molecules of diethyl ether. Let's turn our attention to the key question number 3. So calculate the number of molecules in 23.14 grams of diethyl ether. So now we're starting from the mass of our compound or molecule. We'll convert to the amount of substance and then to the number of molecules. So convert to the amount of substance and then the number of molecules. The calculation would look something like this. We start with our mass, then we use the conversion factor, and it's the molar mass, but in a sense it's the reciprocal of the molar mass, to convert our mass to the amount of the diethyl ether in moles. We then take that amount and multiply by Avogadro's number to find out the number of molecules. Now, one of the things that you're asked in this question, as well as in question number 2, is whether these answers make sense. So I'm going to come back to the previous problem just for a minute. So notice in this key question number 2, we start with 3.011 times 10 to the 23 molecules. And in relation to Avogadro's number, I hope you can see that this is exactly half of Avogadro's number. So therefore, the mass in grams that I would expect would be, let's say, half of the molar mass. So this answer of 37.06 grams makes perfect sense. And then moving forward to the next question to ask, well, does it make sense? I start with 23.14 grams. I know the molar mass is 74.12 grams. So roughly 23.14 grams is maybe 1/3 of a molar mass of my diethyl ether, and 1.880 times 10 to the 23 molecules is roughly 1/3 of Avogadro's number. So indeed, all of this does make sense. So these kinds of calculations are similar to what we saw in the chem activity number 5. Here's where things get a little different. So this relates to the teaching model number 3, and you see this diagram right here. When you're working on assignments, your sapling homework, or even when you're doing your midterm, you may want to have this diagram available to you. because it helps keep you organized in terms of the sorts of conversions that are necessary. In this activity, we just explored the conversions in the upper part of this diagram. In chem activity number 5, we looked at the conversions in the bottom part of this diagram. The conversion factors are quite similar. So for instance, anytime we are going from mass to the amount of substance, or back in the other way, we need to make use of the conversion factor of molar mass. Anytime that we're doing conversions between molecules in the amount of substance, or atoms or particles in the amount of substance, it would be Avogadro's number. What's new in this diagram is converting between the amount of substance in moles for, let's say, our compound and molecule, and the amount of substance in terms of the number of atoms that are in that molecule. Now, we saw a little earlier when we were looking at molecular formula that it will be the molecular formula that allows us to make this conversion. Our molecular formula is the conversion factor for this. So let's look at a pre-worked example that's found in your activity. So this is part of teaching model number 3, but it's found on the next page. Here we're asked to calculate the number of hydrogen atoms in 23.0345 grams of ethanol. Now I'm going to refer you back to the chart that we were just looking at to see how we would use this chart to organize ourselves. We have to be careful in making sure that we know what we're looking to calculate. Are we looking to calculate the number of atoms or the number of molecules? In this case, it's clear we're trying to calculate the number of hydrogen atoms. Where are we starting? Well, we're starting with a mass of ethanol. So in terms of this chart, we're starting at this spot, that is the mass in grams of a molecule. The only thing that we can do in a sense with that mass is to convert it to the amount of substance for that molecule, that is the moles of that molecule, and then use the molecular formula as the conversion factor to find the amount of substance of hydrogen atoms, and then finally calculate the number of hydrogen atoms. So you can see that this is also reflected in our unit plan. Mass of compound in grams, the amount of molecules in moles, the amount of H atoms in moles, the H atoms. And then again, this is reflected in our actual calculation. The mass of the ethanol, use the next conversion factor to calculate the amount of our ethanol in moles, then use our molecular formula to convert to the moles of H atoms, and then finally the number of H atoms using Avogadro's number. Let's look at the key questions 4 and 5. In key question number 4, we're trying to calculate the mass in grams of a compound, and we're starting with a number of carbon atoms that are in that compound. So using this chart, we're starting with the number of atoms of carbon. The only thing that we can really do is to convert that using Avogadro's number to the amount of substance, or the amount of carbon atoms in moles. Then use the molecular formula to convert the amount of carbon atoms in moles to the amount of diethyl ether molecules in moles. And then finally, once we know the amount of diethyl ether in moles, we can figure out what is the mass of our compound. So this is reflected in the following unit plan. Atoms of carbon, the amount of carbon, the amount of our diethyl ether, and then finally our mass of diethyl ether. Once you've made that unit plan, then the calculation, hopefully, is straightforward to you. Here are the number of atoms. Here's the conversion to the moles of carbon, or the amount of carbon. Note that I've simplified the calculation a bit by actually dropping the atoms, like 1 mole of carbon atoms. I'm just saying 1 mole of carbon. And then we convert to, using the molecular formula, to the amount of our compound. And then finally, once we know the amount of our compound in moles, we convert to the mass of our compound, 0.375 grams. Let's now turn our attention to the key question number 5. In this case, we're starting with a mass of elemental carbon. and we're trying to calculate the mass of a compound. In terms of our chart, we're starting here. Mass of carbon. The only thing that we can really do is to convert that to the amount of carbon atoms. After we know the amount of carbon atoms, we use the molecular formula to find the amount of diethyl ether in moles. Once we know the amount of diethyl ether, we can calculate the mass of diethyl ether. The unit plan would look something like this. Mass of carbon, the amount of carbon. Once you know the amount of carbon, you know the amount of the diethyl ether. Once you know the amount of diethyl ether, you know the mass of diethyl ether. And again, I believe the calculation just unfolds very naturally. The mass of carbon times the reciprocal of the molar mass to convert that mass to amount of carbon atoms in moles. Use the molecular formula and the understanding that there are 4 moles of carbon for every 1 mole of diethyl ether. So now we've got the amount of diethyl ether, and then multiply by the molar mass. In our synchronous sessions, we'll do some practice in doing these sorts of conversions.